Did you try the homework, Humera?
Ma'am, I will send you by Friday answer.
Okay, do the homework, and if you get any problem in the homework, mark that thing. We'll study. So I'll solve that problem in your next class. Whenever after homework, whenever your next class is scheduled, I'll solve that problem in there. ठीक है? So कहाँ तक पढ़ा था हमने?
We completed the first chapter
We have
and
completed the
started
first
the
chapter. We have
fourth.
started the fourth chapter. I think we have just started the chapter. एक topic हमने पढ़ा था. We were studying the Cauchy-Lewis approach to chemical bonding, right?
Yes, ma'am. Ma'am, can you continue? No, can you start chapter 2? Because
Okay, no problem. I don't have any problem. Chapter 2 मेरे लिए बहुत easy है because I have just taught chapter 2. Let's start with chapter 2. Any other chapter? सोच लो फिर से एक बार.
yes, ma'am, chapter.
Okay, let's start with chapter number 2. So chapter number 2 is basically structure of atom. See, Mera, I'm warning you before only. This chapter is a bit theoretical. इसमें थोड़ा सा you will have to learn, okay? And also this chapter is a bit numerical too. इसमें you'll get many formulas, and there will be time जहाँ पे you won't get anything. कुछ समझ में नहीं आ रहा होगा, ठीक है? But what you have to do is you have to just stick to the chapter. You have to follow me. You have to follow whatever I'm saying, and you'll get this chapter very easily. ठीक है? Don't panic. कुछ समझ में नहीं आ रहा है, कैसे होगा क्वेश्चन, क्या होगा? I'll make you do everything. ठीक है?
Okay, ma'am.
Okay. Let's start with structure of atom. See, from the chapter only you can understand कि यहाँ पे हम क्या पढ़ेंगे. We will study कि how is atom made up of, atom के अंदर क्या क्या चीजें हैं, कैसी सारी चीजें हो रही, ठीक है? Yes. So we all know that atom is made up of uncuttable or undivisible particles. पहले जो whatever the studies were made earlier, वो यही कह रही थी कि atom is made up of undivisible particle. ऐसे चीजों से बना हुआ है कि वो divide नहीं हो सकती and all these things. ठीक है? और also Dalton's atomic theory also said this only कि atom is made up of undivisible particles. Matter is made up of undivisible particles called atom. ठीक है? Atom को कहा गया था it is not divisible, right? But as the scientist did research and all the studies were made, there were the discovery of subatomic particles also. ठीक है? बाद में मालूम पड़ा कि there are some subatomic particles which exist, which are there in the nature, and which तब we don't know about them. ठीक? सबसे पहले we'll study about discovery of electron. ठीक है ना? In the first page NCERT is only saying कि whatever we were thinking कि there is atom is undivisible and all these were all not true. जैसे जैसे साइंटिस्ट आगे बढ़े, they knew that there are subatomic particles which exist. ठीक है? Okay. Now, an insight into the structure of atom was obtained from the experiments on electrical discharge through gases. कैसे मालूम पड़ा, कैसे we have got the subatomic particles? We have done experiments on which, on कहाँ, किस पे? Gases पे. क्या किया हमने? We have discharge through gases. What we had done, we had basically what we have done. We have introduced something like, you can say, high voltage thing, high voltage current into the gases, and from there we have discovered the atomic gases, atomic subatomic particles. Okay. Acha. Before moving to the subatomic things, subatomic particles, what you have to remember is एक चीज कि like charges repel and unlike charges attract. अच्छा, what do I mean by like charges and unlike charges? Like charges means plus plus हो गया, minus minus हो गया, ठीक है. Unlike charges means plus and minus. So same charges will repel each other and unlike charges will attract each other. ठीक है, ये चीज keep in mind. Now, how did discovery of electron occur? Let us start. In 1830, there was a scientist named Michael Faraday. What did he do? He showed that if we pass electricity through a solution of electrolyte, electrolyte electrolyte क्या है? एक solution है, ठीक है, जिसमें electrodes लगे हुए. Okay, electrolytes are solution in which electrodes are there and chemical reaction is occurring there. ठीक, so chemical reactions that is occurring through electrodes and that is occurring through electricity, that is electrodes, electrolytes. ठीक, अच्छा, what did he say? That when we pass electricity through the solution which have electrodes in that, there is a deposition of matters at the electrodes. ठीक, क्या कहा उन्होंने? Let us see. He said we have a container, we have a solution, ठीक है, इसमें there are electrodes, you can say positive and negative, there is a solution in that, ठीक है, solution है. Whenever electricity is passed through it, you'll see कि something is deposited on this electrode. इस electrode पे there is something deposited. ठीक है, what did he say? Michael Faraday ने ये कहा. अच्छा, इसके बारे में और he said this and he formulated some laws जो हम लोग क्लास 12th में पढ़ेंगे. ठीक है, क्लास 12th में जब when we'll study electrochemistry, so we'll study कि what were the laws of these things, what were the things Michael Faraday said. All these things will be studying class 12th. He only said this, so अभी आपको इतना ही जानना है कि he said that whenever we pass electricity through a solution of electrodes, तो जो electrodes होंगे, जो rods होंगे, उसपे कुछ deposit हो जाएगा. ठीक. Now, in mid 1850, in 1830, Michael Faraday showed this. In 1850, mid 1850, what happened? Many scientists, including Faraday, mainly Faraday, began to study electrical discharge in a partially evacuated tube known as cathode ray discharge tube. ठीक है, एक evacuated tube से, evacuated tube मतलब वो basically एयर भी नहीं था उस ट्यूब में, there were no air particles also. ठीक है, there was a tube, you can say there was a tube. Okay, उसमें क्या था? उसमें cathode rays थी. ठीक, it is depicted in figure 2.a. Let us see, I'll draw this figure 2.a, what that diagram is. This diagram is somewhat like this. साइन ऑफ बैटरी. ठीक, अच्छा, यहाँ पे क्या है? यहाँ पे वैक्यूम पंप है. वैक्यूम पंप किस लिए है? टू रिमूव द एयर. इट इज अ कैथोड रे डिस्चार्ज ट्यूब. ये हमारा पॉजिटिव टर्मिनल है, ये हमारा नेगेटिव टर्मिनल है. यहाँ से देयर इज हाई वोल्टेज. ओके, ठीक है. सो व्हाट डिड ही से? he said that, अब how is a cathode ray tube made up of? Yes, how is a cathode ray tube made up of? इसको थोड़ा सा एक्सप्लेन किया गया है. Let me read that out for you. So, uh, it is made up of a glass tube that have two pieces of metal that are called electrodes. They are sealed in a glass tube. Okay, sealed का मतलब they are sealed so that air cannot pass through it. Okay, and also gases cannot pass from there, from gases cannot come out from that tube. ठीक. अच्छा. The electrical discharge, can you hear me? My
Yes.
voice is clear? Okay. So
Yes.
now what happens is the electrical discharge through the gases could be observed at very low pressure and very high voltage. तो condition क्या थी इस पूरे setup condition is high voltage and low pressure. ठीक. So what is happening is a particular setup is made up of, and there a very high low voltage, a very low pressure is kept. अच्छा. When sufficiently high voltage is applied across the electrode, current starts to flow. ठीक. जब जब यहाँ से हाई वोल्टेज स्टार्ट किया गया तो यहाँ से करंट फ्लो करना शुरू किया. ठीक. ऐसे करंट फ्लो करना स्टार्ट किया. ओके. नाउ from negative electrode to positive. ठीक है. You know that current is a flow of electron. तो electron कैसे flow करेगा? Electron will move from negative terminal to positive terminal. ठीक. Right? Okay. Now the flow of current, okay, the electron from negative to positive, these were called cathode ray or cathode ray particles. So the electrons which were moving from negative terminal to positive terminal, तो उस टाइम तो हमें पता नहीं था कि ये इलेक्ट्रॉन है, these are negatively charged particles, because we are discovering these elements. तो इन इलेक्ट्रॉन्स को कहा गया कैथोड रे पार्टिकल्स. कुछ मूव कर रहा है आगे, and these were called cathode ray particles. Okay. Achha. The flow of current from cathode was anodes was further checked by making a hole in the anode and coating the tube behind the anode with a phosphorescent metal sulfide. ठीक है. अच्छा, कैसे पता चला? How did they got to know कि current is flowing? So what did they do is, उन्होंने जो हमारा पास ये था ना एनोड, उस पे उन्होंने होल्स कर दिए और उसके पीछे they put a screen. They put a screen, and then what happened is एक fluorescent tube. Fluorescent, what do you know what is fluorescent? Phosphorescent is material zinc sulfide. ये जो हमारा screen था, it was made up of zinc sulfide and it was phosphorescence. Phosphorescence means it will get active when a light strike on. ठीक है. जब उस पे कोई लाइट आएगी या उस पे कोई एनर्जी आएगी तो इट विल लाइट अप. ठीक. तो whenever the electron hit here, whenever that those cathode ray hit this surface, it got light up. एक spot आ गया वहां पे. ठीक. तो when these rays after passing through the anode, strike the zinc sulfide, तो एक स्पॉट, एक ब्राइट स्पॉट, एक लाइटनिंग सा हमें वहां पे दिखा. तो इससे ये मालूम पड़ गया कि समथिंग इज ट्रेवलिंग फ्रॉम कैथोड टू एनोड, जिसको हमने कहा कैथोड रे. ठीक है. तो ये पूरा एक्सपेरिमेंट था. अब उस एक्सपेरिमेंट का क्या रिजल्ट आया, दैट आई एम गोइंग टू रीड इट आउट फॉर यू. ठीक. अच्छा. So the summary I that was the cathode ray starts from cathode and move toward the anode. Summary said that ki whatever those cathode rays are, they are starting from this anode thing. They are starting from cathode and moving towards anode. ठीक. पहला summary this was this. Second क्या था? These rays are not visible. Okay. But their behavior can be observed on a fluorescence or a phosphorescence screen. How? Which they glow when they are hit by them. They glow. ठीक. टेलीविजन पिक्चर ट्यूब जो है, whatever the television thing is, जो हम टीवी देखते हैं, they work on this principle only. ठीक. क्या होता है उसमें? फ्लोरोसेंट स्क्रीन होता है, and when they are coated with fluorescent screen और cathode ray tubes की जो एनर्जी होती है, when they strike that screen, तो हमें चीजें दिखती हैं. ठीक. तो पहला जो हमारा you can say summary थी, पहला जो conclusion था was that कि whatever those rays are, cathode rays are, they start from cathode and then move towards anode. Okay. The second observation was that the second summarization was that they are not visible. Okay, only their behavior can be observed. And how are we observing that behavior? By placing a screen, and whenever that rays are hitting that screen is lighted. And that thing is used in TV screens. Acha. The third thing was that in the absence of electrical or magnetic field, they are traveling in straight line. So these rays, जिसको हम cathode ray tubes कह रहे हैं, when there is no field, electrical field या मैग्नेटिक फील्ड नहीं है. अच्छा, व्हाट इज इलेक्ट्रिकल फील्ड एंड व्हाट इज मैग्नेटिक फील्ड? सी, जब इफ आई एम सेइंग दिस इज अ वायर, ये एक वायर है और इसमें से करंट फ्लो हो रहा है, ठीक है, आई आई करंट फ्लो हो रहा है, तो दिस करंट विल क्रिएट यू कैन से एक ऑरा बनाता है, ठीक है, अपने आसपास. इट स्टार्ट्स, यू कैन से एक पर्टिकुलर जगह पे वो अपना इफेक्ट दिखाता है. दैट इफेक्ट, दैट एरिया अप टू व्हिच द करंट शोज इट्स इफेक्ट इज इलेक्ट्रिक फील्ड. ऐसे ही व्हेन वी हैव अ मैग्नेट, तो मैग्नेट के आसपास भी जितनी दूर मैग्नेट का इफेक्ट आता है उसके आसपास भी देयर इज समथिंग which we can only feel, we cannot see, that is magnetic field. तो जब तक these two fields are not there, जो हमारी कैथोड रे थी which we were discovering, they traveled in straight line. ठीक, ओके, गॉट इट. अच्छा, व्हेन इलेक्ट्रॉन, या अब तीसरा पॉइंट तो ये था कि इलेक्ट्रिक फील्ड और मैग्नेटिक फील्ड प्रेजेंट नहीं थी. अब फोर्थ पॉइंट इज दैट व्हेन द इलेक्ट्रिक फील्ड और मैग्नेटिक फील्ड इज प्रेजेंट, तो क्या हो रहा था? तो इन द प्रेजेंस ऑफ इलेक्ट्रिक फील्ड और मैग्नेटिक फील्ड, द बिहेवियर ऑफ कैथोड रे आर सिमिलर टू दैट एक्सपेक्टेड फ्रॉम अ नेगेटिवली चार्ज पार्टिकल्स. ठीक है, तो जब हमने इस कैथोड रे पार्टिकल पे जब हमने इलेक्ट्रिक फील्ड लगा दी, फॉर एग्जांपल इस पे हमने इलेक्ट्रिक फील्ड लगा दी, या हमने इस पे मैग्नेटिक फील्ड लगा दी. इलेक्ट्रिक फील्ड को ई से रिप्रेजेंट करते हैं एंड मैग्नेटिक फील्ड इज रिप्रेजेंटेड बाय बी. सो व्हेन वी अप्लाइड इलेक्ट्रिक फील्ड और मैग्नेटिक फील्ड ऑन दीज कैथोड रे पार्टिकल, व्हाट हैपेंड? दे बिहेव्ड लाइक नेगेटिवली चार्ज्ड पार्टिकल. ओके, तो उन्होंने ऐसा बिहेवियर शो किया कि अगर कोई नेगेटिवली चार्ज पार्टिकल एग्जिस्ट करता तो इट वुड शो हैव दिस बिहेवियर. इसीलिए इसीलिए इन कैथोड रे पार्टिकल्स को मेटल फैराडे कॉल्ड इलेक्ट्रॉन्स. ठीक, इसीलिए ही कॉल्ड देम इलेक्ट्रॉन्स. द कैरेक्टरिस्टिक्स ऑफ कैथोड रे, उस टाइम जिसको कैथोड रे कह रहे थे और बाद में इलेक्ट्रॉन कह दिया गया, do not depend upon the material of electrodes and the nature of gas. तो ये जो electrons थे ना, it did not depend कि हमने कौन सी गैस से एक्सपेरिमेंट किया है या हमने कौन सा कैथोड रे, कौन सा वो लिया है, इलेक्ट्रोड लिया. ठीक, it was independent of that. So thus we can conclude that electron are the basic constituent of all atoms. So since they did not depend on the type of cathode, anode or cathode used or the type of gases used, so we can say it is a fundamental thing. सब में ही present होगा और सब में same ही present होगा. ठीक है, इसीलिए we have concluded that electrons are the basic constituents of all atoms. Got it? Let me revise it for you again. कैसे इलेक्ट्रॉन की डिस्कवरी हुई? Let me do एक छोटा सा समरी. लेट मी टेल यू. तो 1830 में व्हाट माइकल फैराडे डिड, ही शोड दैट व्हेन वी पास एन इलेक्ट्रिसिटी थ्रू अ सॉल्यूशन, तो केमिकल रिएक्शंस हो रहे हैं. केमिकल रिएक्शंस की वजह से जो इलेक्ट्रोड्स हैं उस पे समथिंग इज डिपॉजिटिंग. ठीक, ये बात वहीं खत्म हो गई. इसकी जो आगे की बात है दैट विल स्टडी इन क्लास 12. ओके, नाउ आफ्टर दैट 1830 में ये बात खत्म हो गई. Now 1850 में, mid 1850 में, there were many scientists which were studying the electrical discharge. अच्छा, what did they do? They took an evacuated tube. What is evacuated tube? A tube जिसमें vacuum हो. Vacuum means absence of air. ठीक है, और उस evacuated tube को they called cathode ray discharge tube. Okay, it was a glass tube in which two electrodes were there. Electrodes means cathode, the negatively charged cathode, and the negatively charged electrode, and an anode which has positive charge. And both the electrodes were connected to a high voltage. ठीक है, अच्छा, अब उसमें गैस डाली गई. There was a gas in that evacuated tube. And when we maintained low pressure and high voltage, we saw that something is traveling from negative cathode to positive anode. Okay? And we cannot see that thing. We were not able to see that thing. उसको the scientist name कैथोड रे डिस्चार्ज. ठीक है, उन्होंने उसको नाम क्या दे दिया, कैथोड रे पार्टिकल्स या कैथोड रेज. अच्छा, कैसे ऑब्जर्व हुआ कि कुछ था. साइंटिस्ट व्हाट डिड दे डू, उन्होंने एनोड में होल्स बना दिए और एनोड के पीछे एक स्क्रीन लगा दी. ठीक, उस स्क्रीन पे when those cathode ray hit that screen, we got some spots. ठीक है, and that spots made us sure that something was traveling from negative to positive. ठीक है, so this was the whole experiment. अब इस पूरे एक्सपेरिमेंट से क्या कंक्लूजन्स निकले. there were 5 conclusions. What was the first conclusion? कि वो जो भी rays थी, whatever was traveling in that cathode ray, whatever was traveling in that glass tube, that was traveling from negative terminal to positive terminal. ठीक है, पहला conclusion ये था. दूसरा conclusion ये था, they were not visible. We can only see them अगर हम कोई प्लेट लगाते हैं, कोई फॉस्फोरेसेंस या फ्लोरोसेंस प्लेट लगाते हैं. अच्छा, व्हाट इज फ्लोरोसेंस एंड फ्लोरोसेंस प्लेट? एनीथिंग जब उस पर कोई एनर्जी हिट करती है तो वो ग्लो करता है. ठीक, फ्लोरोसेंस और फ्लोरोसेंस एंड फॉस्फोरेसेंस स्क्रीन वो होती है कि उस पर अगर कोई चीज हिट कर रही है तो इट स्टार्ट्स ग्लोइंग. ठीक, तो सेकेंड थिंग ये था कि द रेज जिसके बारे में हम बात कर रहे हैं, दैट वाज नॉट विजिबल. दे कैन बी ओनली विजिबल व्हेन अ फ्लोरोसेंस और अ फॉस्फोरेसेंस स्क्रीन इज देयर. ठीक है, और एक छोटी सी पॉइंट ये भी है कि this this technique was used in, you can say, टीवी स्क्रीन. ठीक है, थर्ड थिंग क्या थी कि ये जो भी रेज थी, they were not affected by magnetic when there was no magnetic and electric field, तो वो straight line पे चल रही थी. When we were not applying any magnetic field or electric field, they was traveling in straight line. Fourth point was that कि when we started to apply electrical or magnetic or both or either of them, कोई भी एक लगाओ या दोनों ही लगा दो, तो we saw कि वो जो कैथोड रे पार्टिकल्स थे ना, they started behaving like a negatively charged particles. ठीक, तो इसीलिए at that point they said कि these cathode ray particles are electron. एक नाम दे दिया गया electrons. ठीक, अच्छा, what was the fifth conclusion? The fifth conclusion was that कि साइंटिस्ट ने क्या किया, उन्होंने material of cathode and anode they changed it. They changed the material of cathode and anode, and they also changed the gas in the tube, and they got no distortion in the result पे कोई फर्क नहीं आया. रिजल्ट जैसा पहला था वैसे ही अभी भी था. तो इन सब कंक्लूजन से उन्होंने कहा कि दिस इलेक्ट्रॉन whatever we are talking about, these cathode ray discharge particles, whatever we are saying, that is the basis of all atom. ठीक है, क्यों क्यों कहा, क्योंकि इफ वी आर चेंजिंग द गैसेस, कोई भी गैस ले लो, या इफ वी आर चेंजिंग द यू कैन से द कैथोड्स, द एनोड्स, तब भी चेंज हो रहा है. ठीक है, सो ऑल दीज थिंग्स, इफ वी आर चेंजिंग दीज थिंग, तो वो हमें कंक्लूजन सेम ही मिल रहा है. ठीक, सो that was concluded as कि this these things is electron. Sorry, electron is the basis of the atom. ठीक,
Yes.
okay, this was the discovery of electron. Okay. Then the next topic was that कि how did charge to mass ratio was discovered. अभी क्या हुआ, अभी we only know that there was something that is electron. ठीक है. Hello Abdul Rahman, are you in this class? He left. Okay. So the next thing is, अभी तक what we have studied, अभी तक what we have got from the experiment, कि there were certain things. There is something called electron. अभी हमें उसके बारे में कुछ नहीं पता है कि उसका चार्ज क्या है, उसका मास क्या है. All these things are not known. ठीक है, अभी we'll do more experiment. Scientists will do more experiment and will come to know कि what is the charge on this electron, what is the mass of this electron. ठीक है, let us start this. Okay. Yes. So let us start with the charge to mass ratio. Now, in 1897, there was a physicist named J.J. Thomson. What did he do? He measured the charge to mass ratio. How? By using the same cathode ray tube and applying the electrical and magnetic field. So what did he do? इसी वाले setup में, whatever setup we have studied अभी, उसी वाले setup में he applied electrical and magnetic field perpendicular to the path of electron. See, if the electrons are flowing in this direction, so what did he do? He applied electrical and magnetic field on this direction. Perpendicular to the direction of the electron, he applied the field. ठीक है? अच्छा. What did he do? अब इस देखो इस the first of this chapter is only based on experiments. ठीक है? We only learn, we have to see कि scientist ने क्या experiment किया, कैसे किया. So it is basically a theoretical topic. Just listen them and try to understand. Okay?
Yes, ma'am.
Yes. So let's start. So what did he do? Whatever the setup was, that cathode ray setup, the scientist J.J. Thomson, he applied electrical and magnetic field perpendicular to each other as well as the path of electrons. See, the magnetic field which he applied, they were also perpendicular to each other. There we have three directions, right? X, Y, and Z. So see, if the electrons are moving, for example, I'm saying the electrons are moving in X direction, so he applied magnetic field in the Y direction, and he applied the electrical field in the uh, Z direction. So the magnetic field, the electrical field, and the direction of electron both were perpendicular to each other. ठीक है?
Yes.
Okay. Yes. So let us see. ये थी ये this was all the whole the setup. ठीक है? Now, when only electrical field was applied, electron deviates from the path and hit the cathode ray tube as point A. Now let me draw the setup. एक setup था. Let me draw the setup. Give me a minute. I'll draw the setup for you. This is the screen. Okay. Uh, Give me a minute. My connection is not stable. Yes. Sorry, my internet was not stable. Can you hear me now?
Yes, ma'am.
Yes. So this was a screen, and let me draw the setup. We have a cathode and we have an anode. Okay. So, and this is the rays which are passing. This is the path of electron. Now, what I have done is to apply electrical field. I'm applying it like this. This is the positive and this is the negative. And to apply magnetic field, what I have done, I have placed a magnet over here. Okay, this is the north pole, this is the south pole. Okay. Now what happened when only magnetic field applied? When I only applied the electrical field. when green wala switch is on, so this hit at part A. Check the electron which were flowing that hit at path A. Now, when only magnetic field was applied, this hit as path C. ठीक है, तो what happens, पहले पहले J.J. Thomson only applied electrical field, then J.J. Thomson only applied magnetic field. First it hit at point A, then it hit at point C. ठीक है, now by carefully, when what did he do, he at third time what he do, he applied magnetic and electrical field in such a way that this electron hit at point B. How did he do that? By carefully observing कि how much electric field या कैसे हम इसको adjust करें. By carefully adjusting it, he somehow managed to hit to make the electron hit at point B. ठीक. Now, after doing this, what did he say? Thomson argued that the amount of deviation of the particle from their path in the presence of magnetic field okay, well, sorry, the internet was a bit unstable. I'm fixing it. Give me just 2 minutes, okay? You hear me, Humera?
Yes, ma'am.
Yes, give me 2 minutes. I'll just fix the internet and come back, okay? Just two
Okay.
minutes. Uh, yes, Humera. Is it fixed now? Can you hear me clearly? I have I have connected the Wi-Fi. Okay.
Ma'am, hello.
Yes.
Ma'am, actually, I'm not a student of this class, and can you actually send me the breakout room for, Sania, ma'am?
I don't know
Like,
Sanya, ma'am.
I have breakout room number 2 or something. So I just like, can you transfer me to that one?
Breakout in Nilesh does not have a
Sorry, ma'am.
breakout two has Nabil and Nilesh, not Sanya.
Okay, the anyone which shows Sania, like, can you just transfer me to that one?
I can see Sumaya, but I
Yeah,
cannot
yeah, yeah.
see
Sumaya one,
Sanya.
Sumaya one. Yeah, yeah, yeah. Just that
You
one.
wait
Thank you so
here.
much.
Sumaya one. Okay, I'm trans. Sanya and all are there in your class.
Sorry.
Sadiha, they are in your class.
Uh,
Sanya,
I'm
Madiha,
new in class. Yeah, 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 yeah.
new.
Yes, yes,
Okay,
ma'am.
so I'm transferring you to number 4, breakout room number 4, and
Yeah.
if that class belongs to you. Okay.
Okay, ma'am. Thank you so much.
Yes, Humera, let us go back to our class. So what we were studying is uh, J.J. Thompson, what did he do? He basically, I mean,
J.J.
again,
Thompson,
again.
he did an
Yes.
experiment that
Huh.
he passed the
Electrical and magnetic field
elect-
perpendicular to the direction of the electron, to the path of electron, and he made certain uh, discussion with that. And what was that discussion? Let us see. Okay, I'll make you see. 1 minute. Sorry for the disturbance. It was just internet instability. Okay, can we start?
yes, ma'am.
Yes. So what did he say? What did J.J. Thomson argue? He said that magnitude on negative charge particle is greater than the magnitude of charge on the magnitude of a negative charge on the particle, greater the magnitude on the charge on the particle, greater the interaction with the electrical magnetic field. Acha. He said that the presence of electric and magnetic field. ठीक है डेविएशन व्हाट मतलब डेविएशन डू यू नो व्हाट इज डेविएशन डेविएशन इज कि this is the original path इस original path से how much the thing जो जिस चीज के बात कर रहे हैं that is going to other path ठीक है तो original path से how much that electron is going to another path that is deviation ठीक है so
Yes,
if I'm saying कि जो the electron which we are talking about its original path was B but due to by applying any of the field magnetic or electric field it went to either A or either C so this is the deviation so what did JJ that this deviation depends on the magnitude of negative charge okay what is the value of the charge कैसे how does it depend greater the interaction with the electrical or magnetic field greater is the deflection ठीक है मतलब जितना ज्यादा चार्ज होगा उतना ज्यादा मैग्नेटिक और इलेक्ट्रिक फील्ड से इंटरेक्शन होगा इलेक्ट्रॉन का और उतना ज्यादा रेडिएशन आएगा गॉट इट so first
yes, ma'am.
conclusion, after doing all these experiments, he said this. Second, what did he say? देखो कोई भी चीज जितनी हल्की होगी, हाउ मच लाइटर इट विल डेविएट, एंड जितनी हैवी होगी उतना कम डेविएशन होगा, राइट? फॉर एग्जांपल, इफ यू टेक heavier object and if you take a lighter object and you push it, तो जो lighter object होगा it will move a little faster and the heavier object will move a little slower. तो वैसे ही ज्यादा मास होगा, जितना heavier हमारा इलेक्ट्रॉन होगा, जितना ज्यादा मास होगा वो उतना ज्यादा डेविएट करेगा, और जितना deviate करेगा. So first argument which he made, he said जो deviation है, जो presence of magnetic और electric field की variation है, पहला is depending on the magnitude of negative charge, दूसरा it is depending on the mass of the particle. Okay, so after doing all these experiments he made these two conclusion. The third argument which he made, that the strength of magnetic field and electrical field also decides the amount of deviation. He said if we increase the strength of magnetic field or we increase the voltage of the current, तो deviation ज़्यादा हो जाता है. He said that if we increase the amount of magnetic field or if we increase the voltage, deviation is more. So if the charge is more, the deviation is more. If the mass is lighter, the deviation is more. If the strength of electric and magnetic field is more, the deviation is more. So in the he after doing all these experiment ki electric field lagaya, magnetic field lagaya and uska deviation dekha, he made these three conclusions. Okay. Okay. Now, after all these whatever he did this experiment, he carried out some calculation and measurements and he deducted that mass to charge ratio. ठीक है, तो जो charge to mass ratio आया, charge of electron and mass of electron, it came out to be 1.758820 into 10 raised to the power 11 coulomb kg inverse. Abhi we don't know either about mass or the charge, we only know the ratio. ठीक है, तो by doing all these experiments, J.J. Thomson came out with the charge to mass ratio of the electron, ठीक, which was this thing. And after this, by this experiment, आगे के experiment से Milton found out the charge on the electron. ठीक है, by making the basis this इस experiment के basis से he found charge on the electron. ठीक है, so ये दो experiment which we have read, is this clear to you?
Yes, ma'am.
Am I a little slow or this speed is okay for you कि थोड़ा fast करें हम?
Ma'am, this is okay.
Okay ना, right? Because this is an explanation chapter, थोड़ा theoretical chapter है, तो if I'll go fast you'll get nothing, इसलिए I'm not going a bit fast. अभी chapter number 3 जो है उसमें I'll speed up, so it will cover. Now, how we have found out the charge to mass ratio. Now we will find out the charge on the electron. How we will do it? Millikan, there was a scientist R. A. Millikan. He did an oil drop experiment. Achha, what did he do? To oil drop experiment say, he did the experiment to find out the charge on electron. Okay. He found out that we don't have to study the experiment, we only have to do the conclusion. He found out that the charge on electron was minus 1.6 into 10 raised to the power minus 19 coulomb. Okay. अच्छा, and now the present accepted value is, अब क्योंकि science has evolved, so the present accepted value of charge is 1.602176 into 10 raised to the power minus 19 coulomb. अब ये minus क्या कह रहा है? This minus only says that it is negatively charged. इस minus का इस magnitude से कुछ लेना देना, it does not mean की value कम ज़्यादा, नहीं, it only indicates that it has negative charge. ठीक है, now since Millikan found out the charge on the electron. So by combining the J.J. Thomson experiment and Millikan's experiment, mass of electron was also found out. कैसे? E upon m हमें पता था, it was this, and if we divide it again, अगर हम फिर से इसको e से मल्टीप्लाई कर दें या 1 upon e से मल्टीप्लाई कर दें, so we can find out the mass. So then we multiplied this thing by charge of electron, 1 upon charge of electron. The mass of electron came out to be 9.1094 into 10 raised to the power minus 31 kg. ठीक है? So up to here we studied 3 experiments, and by these 3 experiments found out the charge on electron, the mass on electron, and mass to charge ratio. ठीक है? So these are the 3 experiments which were the basis of finding the key factors of electron. ठीक?
Yes, ma'am.
Okay. Now let us move आगे. आगे क्या है भाई देखते हैं. Now we have studied discovery of electron. Now we will study discovery of other particles which are proton and neutrons. ठीक है?
Ma'am, your voice is lacking.
यार. Can you hear me now?
Yes, ma'am.
Okay. Yes. So by these 3 experiments, we came out with the charge, mass, and charge to mass ratio of the electron. ठीक है? Now let us move to the discovery of electron, proton, and neutron, the other subatomic particles. Okay. Let us see how was that experiment. Now, can you hear me?
Yes, ma'am.
Give me a minute. Let me put this tab on the charging. Yes. Now let us study the discovery of neutrons and electrons. Acha. The same experiment which was done in cathode ray tube, उसको थोड़ा सा modify किया गया. क्या modify किया गया? कुछ we don't have to study. Okay, we only have to study some modification was made and canal rays were discovered. ठीक, जैसे कैथोड रे डिस्कवर की गई थी वैसे ही canal rays were discovered, and these canal rays were called positively charged particles. ठीक, उसका experiment we don't have to study, we only have to see the conclusion of that. What were the conclusion? What were the properties of that? We only have to see properties. What were the properties of those positively charged particles? The first property was that unlike cathode ray, mass of positively charged particle depends on the nature of gas present in the cathode ray. ठीक है? हमने क्या देखा था? हमने देखा था कि electron, the mass, the charge, whatever the thing was discovered in cathode ray, that was not dependent on the nature of gas or the nature of anode or cathode. But these positively charged particles, they were dependent on the cathode and anode ray tubes. ठीक है? But they were dependent on the nature of gas. ठीक? If we change the nature of the gas, the mass of the positive particle changes. ठीक? अब ये क्यों हो रहा था? अभी when we will study the second part of this chapter ना, जहाँ पे we will study the atomic mass, atomic number, तब you will get to know कि why the positively charged particle का mass was changing when we were changing the gas. ठीक है? वहाँ पे को याद दिलाना, I'll explain you this. Okay. The point number 2 is the charge to mass ratio of the particles depend on gas from which they originate. ठीक, तो इन्होंने कहा कि since mass was different for different gases, so charge to mass ratio was also different for different gases. Okay. Again, is it lagging? Point number 3 was some of the positively charged particles carry a multiple of fundamental unit of electric charge. What did they say? He said that जो हमारा negative charge था, that was not equal to the positive charge. It was a multiple of the electrons. Some of the positively charged particle carry a multiple of the fundamental unit of electric charge. ठीक, इसका भी clear is जब when we finish the electron proton discovery, you will get clear with this. This was the third conclusion. Fourth property क्या थी? The behavior of these particles in the magnetic and electric field is opposite to that of the cathode ray. Cathode ray का क्या था कि if negative charge is more, deviation is more, तो यहाँ पे उल्टा हो रहा था. पॉजिटिव चार्ज कम होगा तो डेविएशन ज्यादा होगा, heavier mass होंगे तो डेविएशन कम होगा. ठीक है, it was a totally different, just opposite. ठीक. Now the smallest and the lightest positive ion obtained was from hydrogen, इसलिए उसे प्रोटॉन कहा गया. ठीक. So the positive ion which was observed that was obtained from hydrogen, तो इसीलिए उसको कहा गया प्रोटॉन. ठीक.
Yes.
Okay. Then क्या हुआ? The positively charged particle was characterized in 1919. Later, a need was for the presence of electrically neutral particle as one of the constituent atom. See, 1919 में positively charged particle मिल गया. But जब positively charged particle और negatively charged particle था, तो then the scientists felt a need of something else also, कि एक neutral charged particle भी चाहिए atoms में. See, there must be a neutral charge. डिस्कवर नहीं हुआ है. So they discovered a neutral element in 1932 में. Chadwick discovered, what did he do? He did an experiment. What was that experiment? I बता रहे हैं. By doing that experiment, he discovered neutrons. What did he do? He took a sheet of beryllium. ठीक है, a thin sheet of beryllium he took, and what did he do? इस thin sheet of beryllium में he bombarded alpha particles. ठीक है, alpha particles क्या होते हैं? Alpha particle is that we have helium. ठीक है, helium have 2 electrons and 2 protons. ठीक, तो इसका एक इलेक्ट्रॉन निकाल लो, so it will be helium plus. तो helium plus को we call as alpha particle. ठीक, तो what did he do? एक बेरिलियम की शीट ली, उस पे ही बम्बार्डेड अल्फा पार्टिकल्स. अच्छा, उसके बाद क्या हुआ? Alpha particles when he bombarded, so when electrically neutral particles having a mass slightly greater than the mass of proton were emitted, so when he bombarded alpha particles, तो यहाँ से कुछ निकला, यहाँ से कुछ बाहर निकला, और वो क्या था? वो था उसका मास थोड़ा सा, वो जो भी था XYZ जो भी था, उसका मास was a little heavier than alpha positive charge. ठीक, slightly greater than that of protons. इलेक्ट्रॉन नहीं, वो देख लिया गया, it was not electron, उसको मेजर कर लिया गया. जब उसको मेजर किया गया तो it was slightly heavier than proton, और उसको चैडविक ने न्यूट्रॉन्स. ठीक, and the important properties of all these electron, proton and neutrons अभी I am listing here. ठीक, the important properties of all these things are this. See, we have 3 subatomic particles: electrons, protons and neutrons. ठीक, electrons पे charge is -1.60276 into 10 raised to the power -19. protons पे भी same charge है, बस इट इज पॉजिटिव. सी पॉजिटिव प्लस और माइनस का मतलब होता है it denotes the negative and positive thing. It does not denote the value. ठीक है, values are both same. This is the charge and neutron has zero charge. Now since it is a big value, है ना, ये बहुत
Ma'am, your
बड़ी
voice
value है.
is not coming.
हेलो 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 हेलो. अभी क्लियर हुई?
Yes, ma'am.
हाँ.
Ma'am, you
So
were
see,
saying something about the positive and negative sign.
हाँ, this negative sign and this positive sign does not change the value of charge. They only represent कि ये charge जो है ये electron का है and this charge is of proton. It does not have to take anything on the value. The values are equal. ठीक है?
Yes, ma'am.
क्या मसला है? Is it clear now?
Yes, ma'am.
Yes. So the positive negative charge doesn't have to take anything with the magnitude of the charge. They only represent the that अगर कहीं I write 1.6 in 10 to the minus 21 with a positive charge, तो इसका मतलब it is representing a proton, and if I write with negative sign, इसका मतलब it is representing an electron. Magnitude दो का equal है. Okay?
Okay.
अच्छा. Now since C it is a very big value, जब हम calculation करेंगे, so we'll not take this much big value. What do we take? We take a relative value. Relative value क्या होती है? हमने रेशो ले लिया दोनों का. जब रेशो लिया तो इसका came out to be -1 and इसका came out to be +1. ठीक है, कैसे लिया? इसी के चार्ज से इसी को डिवाइड कर दिया. इलेक्ट्रॉन टू प्रोटॉन रेशियो इलेक्ट्रॉन टू इलेक्ट्रॉन चार्ज एंड इलेक्ट्रॉन टू प्रोटॉन चार्ज रिलेटिव चार्ज है बेसिकली. किसी एक को फिक्स कर दिया, उससे डिवाइड कर दिया. ठीक है, तो हमने क्या किया? हमने इलेक्ट्रॉन को पहले इलेक्ट्रॉन से डिवाइड किया, फिर इलेक्ट्रॉन को प्रोटॉन से डिवाइड किया. दोनों का ही 1 आया. नेगेटिव चार्ज से कुछ लेना देना नहीं. ऐसा मत समझना कि ये मैथ्स वाला नेगेटिव पॉजिटिव. इफ आई एम सेइंग -4 and +4, so +4 is greater than -4. No, यहाँ पे 1 and 1 both are equal. This negative and positive only represents electron and proton. ठीक है? Okay. Let's move again. Now then we have mass. Mass of electron was 9.109328 into 10 raised to the power minus 31 in kg. Okay. Proton का 1.6726 into 10 to the power minus 27 in kg. And neutron का 1.674927 into 10 raised to the power minus 27 kg. ठीक है. अब अगर हम यूनिफाइड मास में देखते हैं तो इट वाज 0.00054 and it was 1.00727 and this was 1.00867. ठीक.
Yes,
So
ma'am.
these were all the properties of electron, proton, or neutron: charge, relative charge, mass in kg, and mass in unit mass. इसको अप्रॉक्स करोगे तो ये 0 आएगा. It will come out to be 1. It will come out to be 1. Approximate mass. तो electron is basically you can say approximately massless, but nothing is massless. Matter है तो उसका mass होगा. ठीक है. So this was all the you can say properties, all the explanation which was given by all the scientists to discover subatomic particles. ठीक है. Now we'll start with atomic models. Atomic models क्या है? Observation obtained from the experiment mentioned in the previous sections have suggested that Dalton's individual atom is composed of subatomic particles carrying positive and negative. So अभी तक whatever we have studied, whatever scientists have given us, discovery of subatomic particles was to account for the stability of atom. अब subatomic particles आ गए हैं. Hello.
Yes.
So now, since all these experiments were made, electrons, protons, and neutrons were discovered. So the major issue before scientists was that कि अब since atom consists of all these things, तो atom की stability बतानी पड़ेगी. How is any atom stable? What will be the value of these charges कि atom gets stable? And to compare the behavior of elements, since every element will have a different number of electrons, protons, and neutrons. So every element will have different physical chemical properties, right? So that also scientists have to explain. Also, why, how are different compounds, yeah, how are different atoms being made by combination of these different atoms, ये भी explain करना पड़ेगा scientist को. और क्या scientist को explain करना पड़ेगा to understand the origin and nature of characteristics of electromagnetic radiation absorbed and emitted by the atoms. अब ये जो atoms थे, ये जो subatomic particles थे किसी भी atom के अंदर, they were absorbing some radiations and some of them were emitting also. So that also was a challenge for the scientists to explain. Okay? So after all these discovery, scientists were trying to explain all these things by giving different atomic models. ठीक. अच्छा, अब किसका एटॉमिक मॉडल एक्सेप्ट हुआ, किसका रिजेक्ट हुआ, किसके में क्या प्रॉब्लम थी, किसके में क्या प्रॉब्लम नहीं थी, दैट विल स्टडी अभी आगे. पहला मॉडल व्हिच वी हैव टू स्टडी इज थॉमसन मॉडल ऑफ एटम. This might be our last topic for today's class. So the topic is Thomson model of atom. Thomson model of atom, you might have heard plum pudding model or watermelon model. That was Thomson model. What did he say? In 1889, he proposed that he said that atom is spherical in shape. ठीक है, he said कि एक atom है that is spherical in shape. ठीक है, मान लिया spherical in shape. इसका जो radius है that is approximately 10 raised to the power minus 10 meter. 1 angstrom का इसका radius है. ओके, ये भी मान लिया. एंड देन ही सेड कि इस जो ये जो बॉल है ना, ये जो स्फीयर है, इस पे जो पॉजिटिव चार्ज है दैट इज डिस्ट्रीब्यूटेड ऑल ओवर द चार्ज. मान लो फॉर एग्जांपल यू हैव अ सॉलिड बॉल, जो सॉलिड बॉल का मास है दैट इज पॉजिटिव चार्ज. ठीक, गॉट इट?
Yes, ma'am.
So he said the atom is spherical in shape, and that's on that sphere positive charges uniformly distributed. और उसमें जो नेगेटिव चार्ज है, जो इलेक्ट्रॉन है, दैट इज एम्बेडेड, कहीं कहीं पे प्रेजेंट है ऐसे. he proposed this thing. अच्छा, अब इसको अलग अलग नेम दिया गया. इफ यू कंपेयर इट विथ अ वाटरमेलन, तो वाटरमेलन कैसा होता है? देखो ये वाटरमेलन है, और ये इसका रेड पार्ट हो गया, इस पे इफ आई डू दिस थिंग विद अ ब्लैक, तो ये उसकी सीड्स हो गई. right? So it just looks like a watermelon, जिसमें the red part is the positive charge and the seeds are the negative charge, right? Also it can be called as pudding model. Plum pudding model क्या हो जाएगा? If you see a plum, तो plum का जो hard part है, that is the you can say proton, और उसमें जो seeds हैं, that is electrons. रेजिन मॉडल, रेजिन पुडिंग मॉडल कह दो कि जो खीर होती है, खीर में द वाइट पार्ट इज द प्रोटॉन एंड द ड्राई फ्रूट्स इन दैट, द रेजिन्स इन दैट आर द इलेक्ट्रॉन. ठीक है. सो जे जे थॉमसन ने ये मॉडल प्रपोज किया. ठीक. अच्छा, also this model was able to explain overall neutrality of the atom but was not consistent with the later experiment. अच्छा, this experiment was able to explain कि why is any atom neutral. ठीक है. बट आगे जो रिजल्ट्स आए, this atom was not able, this model was not able to explain that. क्या आगे रिजल्ट आए? अभी 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 जो आगे साइंटिस्ट ने मॉडल दिए हैं, उसमें इनकी क्या कमियां थी वो एक्सप्लेन की गई. Also he was awarded Nobel Prize in Physics in 1906 for his investigation on gases. इस पे नहीं, गैस की इन्वेस्टिगेशन पे he was awarded Nobel Prize. तो प्लम पुडिंग मॉडल, जे थॉमसन मॉडल ये था. Then came Rutherford model. Rutherford का मॉडल क्या था? What did he do? He took alpha particles. ठीक है. He took a photographic plate and he took a golden foil. अच्छा, उन्होंने अल्फा पार्टिकल की बम्बार्डिंग कराई गोल्ड फॉइल से, और उसके बाद उसका रिजल्ट देखा. ठीक है. उसका एक्सपेरिमेंट, उनका एक्सपेरिमेंटल सेटअप क्या था? लेट मी एक्सप्लेन यू. This I'm saying is a source of alpha particle. यहाँ पे एक शीट है, राइट, एंड यहाँ पे दिस इज अ स्क्रीन, और यहाँ पे एक गोल्ड फॉइल है. Why gold foil? Because gold is a metal and metal can easily be converted into sheets. ठीक है. तो गोल्ड लेने का रीजन ये था कि a very thin sheet of gold can be made. ठीक. तो he did this. Now अल्फा पार्टिकल्स यहाँ से निकाला गया. ठीक. it bombarded scattered अलग अलग डायरेक्शन में, तो उसकी वजह से कुछ कंक्लूजन्स निकले. ठीक है. व्हाट वाज दोस कंक्लूजन्स? लेट अस सी. पहले लेट अस सी कि क्या एक्सपेरिमेंटल सेटअप था. What was the experimental setup? The experimental setup was that Rutherford and his student bombarded very thin gold foil with alpha particles, जिसको alpha particle scattering experiment कहते हैं, which is represented by this diagram. What happened? एक high stream ली गई alpha particle की, किससे? Radioactive source. This was a radioactive source. ठीक है. अच्छा, the thickness of this gold foil was 100 nanometer, very small. ठीक. And a zinc screen was there. when the alpha particle hit the gold foil, तो एक flash, when the alpha particle hit that screen, एक flash of light produce हो रही थी, जैसा कि हमने पुराने वाले experiments में देखा था. अच्छा, now results जो थे that were very unexpected. क्यों? क्योंकि उससे ये पता चला कि whatever थॉमसन वर सेइंग उससे बहुत अलग एक्सपेरिमेंट्स ऑब्जर्व हुए थे. क्या एक्सपेरिमेंट ऑब्जर्व हुए थे? He saw that कि most of alpha particles, जो alpha particles थे, they were undeflected. they जैसे undeflected मतलब जिस डायरेक्शन में वो आ रहे थे उस डायरेक्शन में they went आगे. Only a small alpha particles were deflected and only a few bounced back. ठीक है, कुछ बहुत कम डिफ्लेक्ट हुए और एक आध जो थे उन्होंने अपना पाथ रिट्रेस कर लिया. अगर इसको हम आपको और अच्छे से दिखाएं तो ये कुछ ऐसा होगा कि सी if this is the arrow, if these are the arrows which are representing the direction, ठीक ये हो गया. I'm making a rough diagram, and these are alpha particles. Okay, these are alpha particles, and a thin gold foil ये हो गई. तो ये कुछ ऐसा thin gold foil को जो only a few deflected, तो जो deflected वाले थे, I'm showing this. Only a few deflected. ठीक है, and 1 in 20,000. If I'm saying I have taken 20,000 alpha particles, तो इसमें से कोई एक होगा जो अपना पाथ वापस ट्रेस कर लिया. ठीक, so this was the experimental result which came out. This was the conclusion, this was the result जो रदरफोर्ड को उनके एक्सपेरिमेंट में मिला. अब इससे उन्होंने क्या कंक्लूजन निकाला या इससे उन्होंने क्या चीजें निकाली, that is a long discussion that we won't do in this class, that we'll do in next class. तो अभी we have studied इलेक्ट्रॉन की डिस्कवरी कैसे हुई. इलेक्ट्रॉन की डिस्कवरी हुई कैथोड रे ट्यूब से, राइट. कैथोड रे ट्यूब में एनोड्स और कैथोड्स लगाए गए, इलेक्ट्रिसिटी पास कराई गई, कैथोड रे वर पासिंग एंड वी सेड दैट दीस कैथोड आर इलेक्ट्रॉन्स. ठीक है, कैसे कहा, इलेक्ट्रिकल और मैग्नेटिक फील्ड लगा के. ठीक, अच्छा. उसके बाद we discovered protons and neutrons. Protons were discovered by canal rays, neutrons were discovered by Chadwick, by alpha particles and beryllium. ठीक है, उसके बाद we studied, we had said कि several atomic models came to state the stability of these electrons. ठीक है, ये इलेक्ट्रॉन, प्रोटॉन और न्यूट्रॉन्स या एटम की स्टेबिलिटी को बताने के लिए, हाउ इज फिजिकल और केमिकल प्रॉपर्टीज बताने के लिए, ऑल दीज थिंग, टू एक्सप्लेन ऑल दीज थिंग, डिफरेंट atomic different, you can say, atomic orbitals are, sorry, different atomic models are. Okay, सबसे पहला मॉडल जो आया that was J.J. Thomson's model. J.J. Thomson model also called plum pudding model या watermelon model. What did he say? He said that atom is a sphere and the proton is distributed all over that sphere and electrons are embedded in that. ठीक है, नेक्स्ट जो मॉडल आया वो रदरफोर्ड का आया. इन द नेक्स्ट क्लास आई विल स्टार्ट अगेन दिस रदरफोर्ड मॉडल एंड विल स्टडी द दिस फुल. ठीक है, तो अभी तक व्हाटएवर वी स्टडी दैट इज क्लियर टू यू.
Yes, ma'am.
Okay, so do the homework. Abhi I'll not update any homework. Purana homework when we'll finish, then I'll update you homework. When I'll finish those purana homework, then I'll update the homework. And homework के बारे में और कुछ बात है नहीं. When you will do the homework, then we'll discuss. Okay, so whatever we have studied, try to read it once. You'll get clear with this. ठीक है?
Okay, ma'am.
Okay, चलो. ठीक है? See you in the next class.